These are your notes for 5-4, solving systems using linear combinations. You probably have heard of this before, but you probably called the method elimination. Okay, it's the same thing, but they're calling it linear combinations in this book. So, objective and what's the point? I'm going to change my ink color, maybe to pink. You're going to learn how to use the addition and multiplication properties of equality to find solutions to certain systems. Basically, I'm going to teach you the method of elimination today. This should be a review, actually. This is another reliable way to solve systems if you don't have a grapher with you. And the thing that is nice about this is you can use it for more than 2 variables. What I want to mention, I think a lot of kids know this method, but I don't think a lot of kids understand why it works. So today I really want you to kind of focus and concentrate on why this method even makes sense, mathematically speaking. So here's the process. You can write this down, but I don't think you need to. I think you do know this, but you can. The first thing you have to do is line up your equations. You need to make sure your x's are on top of the x's. Y's go with y's. And equals are lined up, and then like your constants are lined up. Sorry, bell alert. Okay, this would be a lined up equation, okay? The second thing you then do is you're going to look for opposites. When I say for opposites, I'm talking about among the variables, okay? You are looking for a case of like x and negative x. X and negative x are opposites. 3y and negative 3y are opposites. 4y and negative 4y are opposites. I don't have any opposites here, and so then I would go down to this next step. If you don't have opposites, you make them. How do you make them? You multiply an entire equation, left and right sides, by a constant. You can do that. That is a mathematically legal move because it does not change the equation of a line if you multiply through by a constant. It just changes the appearance of the equation. So you usually say, am I close to opposites? And it looks like I'm closer here with the x's. I can get a negative x relatively quickly on one of these. I'm going to multiply the entire bottom equation and by -1. I shouldn't do the big parentheses, but I always do. You should do separate like this, but I just don't do that. Okay? Get organized here. You do kind of have to have organized work. So I'm going to move over here to the right. Okay, I still have x plus 3y equals -2. And now I have negative x minus 4y equals -4. This is the step that I don't think kids understand why this works. I don't think I always understood why it works. I just knew what to do. Once you get the opposite, this is why the method is called eliminations. You're going to add straight down so the x's are eliminated. So I no longer have any x's. I now have -1y equals -6. Divide through by -1 and I get y equals 6. Okay? Not quite done. I want to stop though and tell you why that works even. Okay, why am I allowed to add those two equations? Okay, basically when I add these equations going straight down, that is the equivalent to adding -4 to both sides of this first equation. Basically what I'm doing here is I have this x plus 3y equals -2. I think everybody can see that I added -4 to the right hand side, and I think everybody agrees that if I add -4 to this side, I have to add -4 to that side. It doesn't appear that we did that, but we really did. When I add -4 to the right, I added -x minus 4y to the left. That is equivalent to -4 because it says that they are equal. So really what you're doing in elimination is you're adding the same thing to both sides. It's just that the same things look different because -4 becomes -x minus 4y on this side. But the reason the elimination method works is because you're really technically just adding the same thing to both sides of the equation, which does not change the value. Okay? So I have y equals 6. After you find out y, again, we're looking for where these two lines cross, they intersect. We know this because when we solved by graphing, we were looking for that intersection point. I need to plug in y equals 6 to one of my two equations of the originals. Pick your favorite. I like the first one a little bit more. So I have x plus 3 times 6 equals -2. X plus 18 equals -2. Subtract 18, subtract 18. X equals -20. So after you eliminate the variable, we solve for the remaining. We got y equals 6. That's what we did on this step. Plug in to get the last one. I get x equals negative 20. You should write it as ordered pair. You don't have to. It's just a nice way to write it, though. Okay, you have done this before. This is not new. We're going to do 2 more examples, and then we'll call it a day. So here's another example. I have 5x minus 6y equals 3. I think maybe a different color would be a little better. And 2x plus 12y equals 12. Okay, step 1 is to make sure everything's lined up, and it is. Step 2 is to look for opposites. Okay, I don't have opposites in the x's or y's, but I'm kind of close in the y's. That's where I would go. I'm having all sorts of ink problems, guys. Okay, maybe black would be better. I have 12y here. I can change this to negative 12y easy enough by multiplying the entire top by 2. So I now have 10x minus 12y, which is what I needed, equals 6. Make sure everything gets multiplied by that 2. On bottom, I have 2x plus 12y equals 12 still. Nothing changes there. Add them up. Going straight down, I now have 12x eliminated, so it's 0, equals 18. Divide both sides by 12. 3/2. They both have a 3 in common. Okay, not quite done. I still need the y value. Pick your favorite equation. I'm going to pick the bottom one because I'm multiplying by 2 there, and I think that will help me out when I'm using 3/2. So I have 2 times 3/2 plus 12y equals 12. The 2's cancel. 3 plus 12y equals 12. Subtract 3. 12y is 9. Divide by 12. 3/4. Okay, so we have some fractions here, but that's okay. It doesn't say that they have to cross out an integer. 3/2 and 3/4. You can check these by graphing if you want. You can check them by plugging into the other equation. You have lots of options to make sure you're getting the correct answer. Okay, this can be used for more than 2 variables. I won't say it's the most fun thing to do in the world, but it is definitely legal to do so. It does get a little messy, so buckle your seatbelts, okay? You kind of have to be organized. Your goal is first to eliminate one variable if possible, okay? So I always like to look at it in pairs and try to get rid of something. I prefer to look at the top 2 first and then the bottom 2 second, but that's just the way I like to do it to make sure I'm doing things properly. If I'm going to look at the top 2, I have everything lined up. I have x's, y's, and z's. I don't have opposites, but I'm kind of close in the y's. So I'm going to change this to a negative 2y. I'm going to do that by multiplying everything by a 2 on the top, okay? So now I have 4x minus 2y plus 2z equals 4. I'm going to keep the second equation the same. 5x plus 2y minus 3z equals 43. I will add them up. Oops, messed up. 2 times 4 is 8. I'm glad I caught that. You guys are probably all screaming at your computer right now. You made a mistake. Let's make sure I did everything else right. I didn't do it all right. Gosh, 2 mistakes. This is what happens when I make videos at lunchtime. 4x minus 2y plus 4z. See, maybe I should draw those arrows. That might help me. Okay, I hope I didn't make another mistake. All right, I'm going to add them, and I get 9x. The y's are eliminated. I have a plus z equals 51. Okay, so now if I can look at these bottom 2 equations, and if I can get rid of the y again, then I can have a new system of equations. So that's what I'm going to do. I have 2y here. I'm going to change this to a negative 2y, so I can eliminate the y's again. So I have 5x plus 2y minus 3z equals 43. And now I'm going to have negative 2x. I'm multiplying everything by negative 2 here. Minus 2y, which is exactly what I needed, plus 2z equals negative 22. 3x, y's are eliminated, minus z equals 21? You guys can't tell me if I'm wrong anyway. Okay, so now I have another system here. Now I have 9x plus c equals 51 and 3x minus c equals 51. Equals 21. I will apply elimination again. The z's are already opposite, so this is good to go. And I get 12x equals 72. Divide by 12, and I get x equals 6. I'm on my way. I have one of the variables solved. Well, let's try to figure out y. Where do I go to figure out what y or z is actually? Well, you can go back to these second equations to figure out what z is pretty easy. And I'm going to pick the second one here. So plug in the 6. 3 times 6 minus z equals 21. 18 minus z is 21. Negative z equals negative z equals 3. So z equals negative 3. So now I have two variables. Oh, you can't even quite see them. I'm getting a little sloppy here. X equals 6 and z equals negative 3. Still need y. Where are we going to go? Let's go back to this original one. The x plus y minus z equals 11. X is 6. Still looking for y. Minus z becomes plus 3 because it's minus a negative 3 equals 11. 9 plus y equals 11. It looks like y equals 2. You can write it as an ordered triple if you want, 6, 2, negative 3, or you can leave it just as that x equals y equals z equals. It's a doozy. Those are hard, okay? I admit, I think your best bet is to look at it in pairs and then you'll be fine. Just there's lots of room for mistakes. Just really take your time and be careful on those. Gets a little sloppy. Okay, remember the check again. Your solutions are going to make all the equations true. If there's case that there's 3, it'll make all the equations true. Take that extra moment to do so. You can also check with your grapher or substitution if you wanted. And we are going to do elimination. All right, thanks.